What is going on, my AP Human Geographers? It's Mr. M. I am here to go through the review sheet with you for tomorrow's Unit 1 exam. I'm excited. I hope you're excited. Because I expect everybody to do really well tomorrow. Man, I'm hoping everybody does really well. I'm not taking the test, so I know I'm going to do well. Anyways, let's get going. 35 questions. And I'm going to go kind of fast just because you can always stop it and start it and stop it. First off, let's start with the first bullet here. Yeah, you better know your vocab. Alright, that's why I gave you the opportunity to take your vocab home with you. Vocab quizzes looked pretty good yesterday. But we can definitely do better. Make sure you know those vocab terms. Some of them are going to be embedded in the material that we will be covering over the next 45 minutes or so. Alright. So let's go to our bullet here. Make sure that you know each of the following map types. The Mercator map. Alright, let's see if I have a copy of the Mercator map up here for us. See if I can find it. Mercator. Well, let's go to our friend the Mercator map. There it is. Alright. Remember, this is the map where Africa and Greenland look very similar, when in reality Africa's like 10 times larger. It's where Alaska and Brazil look really similar, even though Brazil ends up being a lot larger. Remember, Mercator, designed for European sailors. It's great for finding your direction or for sailing courses, especially near the middle latitudes near the equator. But the further you get to the extremes, north, south, east, west, the more stretch there is. It distorts the size of northern and southern countries along with eastern and western. So the big issue here is area or size. It's tremendously distorted. It's stretched towards the outer edges. And so it's considered by many to be the least accurate map, even though, ironically enough, it's the most popular one. Next up, I'm going to go to the Peters map. Peters map, remember, actually displays Africa with its correct size. Sometimes some people argue it's a little oversized, but this one is going to have Africa in the center, in the middle. It's going to stand out and jump out based on its massive size. And this was done intentionally to put Africa at the center of the map to kind of give it importance by putting it in the middle, unlike what we normally put in North America. The whole idea here is psychologically maybe to bump up Africa in the minds of people and make them recognize just how big, how important it really actually is. This is accurate area, and so the areas are correct on this map, but there are errors when it comes to the other types of distortion. Alright, so area is good, but the other types of distortion all exist on a small level. It's remember, the Peters was largely designed to go after the Mercator projection because it's they considered Mercator to be biased against Africa and the Southern Hemisphere because it gave too much significance or priority to the Northern Hemisphere. Then we have the Robinson projection. Remember, the Robinson projection, if you recall, is a compromise map. Remember, it's the map where there's none, all four types of distortion exist. They do not eliminate any of them. They just try to minimize them, make them as small as possible. And I think that this is actually the best of the maps that are out there, because I think it gives you the most generally accurate of all. Alrighty, so again, Mercator area is distorted, especially at the extremes, at the poles, at the northern and southern hemisphere. Peters area is accurate, but the other three types of distortion exist. Robinson, no distortion is eliminated, but instead what they do is they try to eliminate, or I should say reduce, the amount of distortion that exists for all three. We have a few others as well. We have a goods homosaline map, which is, of course, the map that essentially it's the Robinson map, but what they do is they eliminate the places on the map that people do not live in, because if you're a human geographer, you're studying human activity, obviously places where there are no humans is of less relevance or significance to you. There is one other map you should be familiar with when it comes to these map types, the Azimuthal map. The Azimuthal map is a map that is a circle, and it zones in on one point, usually the North or the South Pole, and then it shows the world as if you were standing on the pole. And so only the polar regions are accurate. Everything else has some sort of distortion. Why would we use this map? Well, pilots use it to fly over the North and South Pole, since oftentimes that might be the shortest distance between two airports. And so again, we don't use azimuthal very often, but you should at least know what it is. It is a map that is centered on a single point, usually the North or South Pole, and then the rest of the map really is depicting Earth as from that single point, from the polar location. Alrighty, let me jump back to our questions. Yeah, I covered Mercator, I covered Robinson, I covered Peters, good homosaline, right, and then azimuthal, which is the point map that we rarely see, but if you get a map that's centered on the North or South Pole, you know immediately that's azimuthal. Thematic maps are pretty easy for us. Thematic maps are pretty straightforward, right? Let's really quickly go through those bad boys and girls as well. Remember thematic maps? We've got the dot map. There it is. The dots are going to represent the frequency of the variable being measured. There's another dot map. There's another dot map, right? Dot, 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 right? Each dot reflecting whatever it is that's being measured on each of those three. Then you get the chloropleth map. Remember, a chloropleth map is going to rank your variable into different categories. So from the most to the least category, whatever it is you're measuring. And remember, the darker the area, they belong to the category that has the greatest frequency. The lighter the category, that's going to be the groups that have the smallest or the lowest frequency. So for instance, if we were measuring the number of automobiles that each person owns on this map, then we would look, for instance, and see the darker areas. Those are the places where people own more cars per person. Lighter areas, people would own less cars per person. All right? Chloropleth, remember, colors, shades. Darker the shade, the greater the frequency. Lighter the shade, the lower that frequency. That was a chloropleth map too. Remember, pop versus Coke versus soda. All right? Let's get to proportional symbol, or graduated symbol, also known as graduated, right? It's a map that uses a symbol or a shape that is different sizes, smaller or larger, to represent the frequency of the factor being measured. This one was Walmart's, remember. Texas had a lot. Montana had very few. Proportional symbol can be any symbol, remember. No matter what the symbol is, it's larger or smaller, depending on what it is that's being measured in each area, right? Proportional symbol, bigger ones mean more of whatever it is being measured. Smaller proportional symbols mean there's fewer in that area. Isoline maps, remember isoline maps look like squiggly line maps, contour maps we sometimes call them. They have this contour design. Remember, they have rings or squiggly lines, and everything within each ring has a certain characteristic. So, for instance, within that area there, the average temperature is 75. In the area around it, alrighty, the average temperature is at least 80, and so on and so forth. Air pressure, right? We have a good example of air pressure. Isoline precipitation, rainfall, right, is another good example of an isoline map. Flow line maps, remember, are maps that demonstrate movement or the flow of ideas, goods, or people. The fatter the arrow, the bigger the arrow from one location to another, the more of a flow there is, the more of movement there is. The smaller the arrow or the thinner the arrow, the fewer or the lesser a flow or a connection there is. Right? Normally, flow lines associated with migration or movement of people or a product. Cartograms. Remember, it's a thematic map in which the theme is substituted for the mass of the land area. So this results in maps that oftentimes look larger or distorted. They make places look larger or smaller than they actually are. For instance, on this population cartogram, India looks way bigger than it actually is, because reflecting the fact that India has one of the largest populations in the world. China also is oversized here. Meanwhile, Canada is very undersized, representing the fact that they have a small population. So ultimately, a cartogram is measuring something, and then for each country or each place being measured, it's going to make them larger or smaller than they otherwise might be, depending on that specific variable. Remember mountaineering deaths as well. That's another good example of a cartogram. That was a good one as well. GDP, the economy as well. All right. Remember, some countries look larger, like Japan, than they are. Some countries obviously appear smaller than they are. And all of Canada, good example. And all of that is because of the cartogram style, which does this intentionally to try to really make an extreme example to jump out at you when you see it. Mental maps, remember, are maps that are basically maps that we create in our minds based on our experiences, our perceptions, our biases and stereotypes, the information we have, our intelligence, I guess you could say, or our education. All of these come together for us to form maps in our heads. Now, they're based on stereotypes. They're based on generalities. So sometimes they're not accurate. Sometimes they're wrong. But a mental map is very important for us because it helps us to identify the ways that the people in an area view themselves. All right? It really helps us to understand how people view themselves. All right? Mental maps, right? Pretty easy. Lots of different examples here. Remember, we even have some that are like based on stereotypes and biases. Those would be mental maps as well. All right, so again, let me make sure I got through them all. Dot map, chloropleth, flow line, isoline, proportional, cartogram, and mental map. Yep, we're through all of them. Okay. What is cartography? Cartography is the science of map making, of making maps. What are the 4 ways that a map can be distorted? Well, remember, the size or area can be distorted. That would mean land masses are smaller or larger than they actually should be on Earth's surface. In addition to that, we have direction, right? Remember, the direction that things face can be off based on how it would actually be on Earth, right? We have shape. Remember, the shape of certain things can be off a little bit. And finally, the distance, right? The distance between locations can be greater or smaller than actually exists. So again, size or area can be off, shape can be off, distance between locations can be off, and direction or facing of certain things can be off. All of those are types of distortion. Remember, every map has distortion because no map, no two-dimensional map is going to be able to completely accurately portray three-dimensional objects. Next question, what are the 2 branches of geography? What's the major difference between the 2? Well, there's a human geography and there's physical geography. Physical geography focuses on physical environmental conditions. It focuses on landforms and climate and vegetation. It focuses on mountains and oceans. And it's based completely on the natural environment and the natural world. We don't use that type of geography very often. We're the other branch in this class. We're human geography. Human geography focuses on where humans are distributed, where they are located, and what are the reasons for that. So, whereas human geography is focusing on humans and culture and their activities, which also sometimes involves how they affect the environment, physical geography is just focused on the environment and landforms. It really doesn't pay attention to human activity at all. Physical geography is the traditional geography that existed like hundreds and hundreds of years ago. It was very popular up until about the early 1900s. Since then, human geography has become much more relevant. When you talk to a lot of folks, they talk about, oh, geography, what is that, maps? What is that, mountains and oceans and stuff like that? Those are people who associate geography with just the physical part of it. They may probably aren't as used to human geography, which is what we are studying. Next question, what are the 4 ways to determine the location of a place? Well, the 4 ways to determine the location of a place are, 3 of them involve what we call relative location. One of them is toponym, right? The name of a place. Each place has its own name, and so that's an easy way for us to be able to immediately recognize a place on Earth. Next is site. Site is when you identify something based on its physical factors. So, for instance, if you describe something based on, is it in a valley or along a river or on mountains? Is it in hills? If you describe the weather there, the climate, the vegetation, the soil. If you're talking about the physical conditions on which a place is located, on which a city, for instance, is located, then you're talking about site. So look for the physical descriptions of a place. And if you see those natural physical descriptions, you know they're describing the site. Situation, remember, is the location of a place relative to other areas around it. So, for instance, if you are describing Catella High School, then you probably are going to want to situate it according to Disneyland. Maybe you want to situate it according to Angel Stadium. You probably want to situate it according to where it is compared to, like, the 57 freeway. So you would find other major landmarks, and then you would describe Catella High School's situation compared to those other nearby places, or just other places. So site, situation, and toponym are all ways that we identify relative location, which kind of means a general location of a place. It's not going to give you the exact spot. What does provide absolute location? Latitude, longitude. All right, that's called mathematical location. We use latitude, longitude in order to pinpoint our location on a map, of course, which we will get to in a question a little bit further down on the page. So again, next question, make sure you can differentiate between site, situation, toponym. Well, I already kind of mentioned that. If it gives a name of a place, that's the toponym. If it's describing its physical features, it's describing the site. And if it's merely giving you the location of a place based on other places, well, that sounds like the situation to me. Pretty straightforward. You should be able to differentiate and be able to say, oh, they're talking about one of these things if a question is about them. Next question, be able to know the basics of latitude, longitude, including the equator, the prime meridian, the international dateline, and the four hemispheres. Oops. And so let's remember, when we're determining mathematical location, latitude, longitude, right, what we do is we divide the Earth up into to halves, I guess you could say. We divide them into a northern and a southern hemisphere by creating an imaginary line known as the equator, which goes all the way around Earth. It's an imaginary line that's kind of the exact center of Earth as a sphere. Then we also have a line running north-south that divides the Earth up into a western and an eastern hemisphere. That line running north and south is known as the prime meridian. It runs through Greenwich, England. The scientists at Greenwich, England, were the ones who kind of came up with the system. That is officially 0 degrees north-south, I guess you could say. So that's 0 degrees longitude, and the equator is 0 degrees latitude. Remember, then what we do is, if you are north or south of the equator, you are either north latitude or south latitude. I should say you are either north or south. And then if you are east or west of the prime meridian, right, you just count the number of degrees you are to the west, or you count the number of degrees you are to the east, and that goes ahead and gives you your mathematical location. So again, what happens with latitude, longitude is Earth is divided into 4 sections. There's a northwestern, a northeastern, a southwestern, and a southeastern, I guess you could say, hemisphere. And you start at 0, 0, right? And then if they tell you, for instance, go 30 degrees north, and then, 60 degrees west, you would find that location on the map. You could pinpoint it down to your exact point. You could get even more further than 30 degrees and 60 degrees. You could even subdivide it into smaller units of measurement, which are called minutes. Alrighty, so ultimately, by using latitude, longitude, you should be able to mathematically determine every location on Earth's surface. You can pinpoint your location. This is what we use when our GPS is telling us how to get from one location to another. Alright? Remember, north-south lines go 90 degrees north and 90 degrees south because they intersect at the poles. Whereas latitude lines, which go flat, lat is flat, remember, they go 360 degrees. They go all the way around. There's no technical connection point like the North and South Pole. So again, north and south you can go up to 90 degrees. East and west you can go as much as 180 degrees. Remember, on the opposite side of Earth from the prime meridian is the international dateline. That's officially that's the line that has to be crossed for the next technically day to begin. Alrighty, so ultimately, on the other side of the Earth from the prime meridian, running north and south, is the international dateline. Alrighty, so latitude and longitude, we did a lot of practice with it. I don't think I need to spend a great deal of time going over it, because I hope, at this point, that we remember it. We know the equator, 0 degrees latitude. We know the prime meridian, 0 degrees longitude. We know the international dateline, right? That's technically 180 degrees on the other side of the prime meridian, and the 4 hemispheres, northern, southern, eastern, western, which are divided by the cross that latitude and longitude make on the Earth's surface. Make sure you know the difference between a large and a small scale map. One might both be appropriate to use. Remember, large scale is when you zoom in. It's going to give you more detail. So quite honestly, if you want to know how to get from your, if you want to get from your home to a concert in Santa Ana, you're probably going to use a large scale map that just includes Anaheim and Santa Ana. You don't really need to see all of California or all of the United States for that. You want a larger scale map that's able to zoom in and give you the information that you need. Small scale maps are zoomed out. Usually with small scale map there's less detail, but there's more coverage. So for instance, if we wanted to see where Spanish is spoken in North and South America, we would need a smaller scale map that included both of those continents. Much smaller scale than, for instance, the map we looked at to find out how to get from Anaheim to Santa Ana. So different uses according to your needs, right? If you need to see more of Earth's surface in order to understand something, then a small scale map will work for you. If you need to see more zoomed in and greater detail of an area, then a large scale map is probably more advisable. What is GPS and GIS? Okay, GPS is Global Positioning Systems. And what a GPS is there are about 14 satellites that are circling Earth right now. That originally were put up by the military. And what happens is, anytime you use GPS, 3 of those satellites zoom in and they triangulate your location. So anytime you use GPS, 3 of these 14 satellites are essentially pinpointing your location. They're triangulating it, which means they're all working together to pinpoint the exact spot that you are at on Earth. And that does take 3 satellites to do this, by the way. And then what it does is it basically assigns you your mathematical location. And then based on that information, it can tell you where you need to go to another mathematical location. It doesn't just say, hey, go up 2 degrees, go to the right 2 degrees. It usually just tells you turn left, turn right until you're there. GPS originally started by the U.S. military. Now it's available to civilians. It's revolutionized geography. And keep in mind, GPS is a type of remote sensing, because remote sensing is anything that is taking pictures from above of Earth's surface, and that could mean pictures on a plane or on a helicopter or on a satellite. Even hot air balloons and things like that, or weather balloons will take pictures of Earth's surface. All of those are examples of remote sensing, and so GPS definitely is a type of remote sensing. What is the purpose of GPS? To find your way, all right, to get from one place to another. It's revolutionized how geography is done. What's GIS? Geographic Information Systems is a computer application, and it's a computer application that uses information, pictures that have been taken of Earth's surface. And then what it does is it creates 3-dimensional computer images or graphics that show you Earth's surface from a digital angle. It looks like a digital screen or a digital layer, 3-dimensional. That recreates the actual Earth's surface. And what's cool about GIS is I can take a picture of Earth's surface, of a map of Earth's surface, and then I can take a picture of the trees and the foliage, and I can take a picture of the water and the traffic and the people and the homes. And then one after the other, depending on what I want to see, I can make those layers, those things, appear on my map, and then I can take them away if I want to as well. So hey, let's say that I want to look at, I don't know, let me find it. Let me find my image of GPS really quickly, please. I think I have it here. Yeah, sweet. So GIS, right? So what I could do is, hey, let's say I want to look at just like the physical landscape. Well, I can start with that. Then I want to check out the soil content. Oh, okay, well, I'll put that soil content on there and overlap it on top of the physical features so I know exactly where on the physical features, like where the soil is the best to grow crops and where it's the worst. Then I also want to see, I don't know, where are there forests in this area as well? Oh, okay. There's the forest layer. Oh, where's the water on in this area? Oh, okay, I'm going to drop the water on there. Oh, wait, I don't want to see the water anymore. Whoops, it's too early for that. I can remove the water from my image. So you can take basically a real image of Earth's surface. You can turn it into 3-dimensional digital images and then you can basically pick and choose what parts of that Earth's surface you want to look at any given time. It's incredibly powerful. It allows us to read, to store, to analyze, and to show data about Earth's surface and maps in a new revolutionary three-dimensional way. We're going to be using GIS this year a couple of different times. You're going to be able to see the power of it. Just know right now it's a computer program, a computer application that allows us to use real images from Earth and create basically digital copies of them. All right? Anyways, GPS is the type of remote sensing, not GIS. Make sure that you can determine density, concentration, pattern. I covered this in class today. Density, remember, is the number. Is more dense or less dense is really determined by counting the number of something. If there's two boxes, the same size box, they've got 5 dots in them and 4 dots in them, and the one with 5 has a higher density. The one with 4 has a lower density because 5 is more than 4. Concentration. Concentration, remember, is it more clustered or is it more dispersed? If things are more smushed together, if they're cramped together, that means it's a more concentrated look. It's more it's more concentrated. It's more clustered. If it is more spread out in a given area, then it is more dispersed, all right, or more scattered. So again, concentration, very easy. Pattern, is there a noticeable pattern that you see with the distribution of something? Do you see a linear pattern or another geometric pattern like a circle, square, or triangle? Or do you see no pattern? Is it random and or irregular, which means it's just, you know, it's distributed in a way that demonstrates no pattern whatsoever. Make sure you can identify the 3 region types: formal, functional, vernacular. Formal regions have a uniform characteristic that spreads throughout evenly, and it has clear, easily recognizable boundaries that kind of tell you when you are coming or going into that area. All right. Functional regions have a node or a center of activity that provides a function that attracts people to it. The further you are from that node, the less attracted to it you are, or the less functional it is for you. Unlike a formal region, functional region barriers usually are not easily recognizable. You don't necessarily know when you're coming or going from one to another. It's not as easily recognizable. It's not clear to the human eye. Let me give you an example. When you are traveling on the freeway and you're listening to a radio station, do you immediately lose reception with that radio station? No. What usually happens is there's a little bit of static, and then a little more static, and then a little more static until it's gone for sure. That's a good example of a functional region, right? Because it's kind of unclear as to when you actually kind of are entering and leaving that particular region area. All right? And of course, perceptual or vernacular regions are pretty straightforward to us. They're regions that are created in the minds of each person, and so therefore, some are more accurate, some are less accurate, some basically, there's going to be some overlap between perceptual regions from person to person, but the boundaries lines are going to be very different and determined by each person. They're going to mean different things to each person, even if there is some common areas within our perceptual regions. There's going to be incredible differences in boundary types. Be able to distinguish between relocation and expansion diffusion. Well, relocation is when people move to a new location and they take their customs with them and start practicing them in the new place, like most ethnic groups do when they come to a new country. Expansion diffusion is when something simply expands outward from the hearth, from the source area. First, it can spread contagiously, which means it spreads in a pretty even pattern outward in all directions, and everybody has the same opportunity to be caught up by it, I guess you could say. Hierarchical, remember, is when it spreads outward, but of course, certain people in certain groups, usually privileged people or powerful or wealthy or connected people, tend to experience the benefits of that first until it eventually trickles down to the rest of us. Reverse hierarchical is the opposite. It's something that generally starts with people that are not connected or wealthy or privileged, but actually are isolated, and then over time the custom becomes so popular that it spreads not only throughout everybody else, all the way up to the highest, most connected hierarchical individuals that are out there. And then stimulus diffusion. Stimulus, remember, is when a product spreads to a new area, it diffuses to a new area, but it changes in some way from its original item or idea Of course, McDonald's in India, always the great example of stimulus diffusion. I hope we know what diffusion types are because you have a lot of practice on them. What are the two general barriers to diffusion? And you need to be able to provide examples of each. Well, the first general barrier are physical barriers. Those would be things like mountains and oceans, which traditionally were the worst barriers to overcome because it was so hard for people to do so. The other category of barrier is cultural barriers. Those could be, for instance, religious barriers or language barriers that prevent something from spreading into a new area. For instance, Muslims tend to have taboos against eating pork. And so, therefore, in many Muslim-dominant countries, pork is not available throughout much of that area because there are religious taboos or bans against it. The same with beef in India. The same with alcohol in certain parts of evangelical Christian areas as well. Okay, so cultural barriers are just cultural reasons why something might not spread, as opposed to physical barriers, which are literally physical objects that stand in the way. What is the relationship between distance decay and space-time compression? I explained this in class today to all of you, but remember, distance decay says the further something is away from a hearth area, the less likely it is to experience that spread, that innovation. Space-time compression says, whoa, distance decay. That may have been true throughout most of history, but in modern times, thanks to technology, internet, transportation, distance decay is lessened. It's much smaller. Distance and time gaps are much reduced now because we can move, we can travel more quickly. Internet and computers and electronics and technology allow us information to fly, to move at the speed of your fingertips. And so the old barriers to diffusion, like distance decay that existed, have become much more reduced in modern times. So space-time compression is almost the opposite of distance decay. Space-time compression is proving that distance decay is no longer as significant as it used to be throughout most of our human history. What are the two primary ways that geographers evaluate what's most important to a culture? Okay, well, they're going to look at the things that the beliefs that a culture thinks are very important. So, for instance, they're going to look at their language. They're going to look at their religion. They're going to look at their view of the world. They're going to look at what belief systems or ideas are especially valuable and important to that group of people because that's clearly what their culture is based on, the mental beliefs. They're known as mentafacts, the mental beliefs that a culture has that can be analyzed by researchers. The other category of ways that we determine the culture of a place is with their artifacts. Those are their material items. So you got their mental items, I guess you could say, or their mental beliefs and traditions. That's the mentafacts. And you've got the artifacts, which are their material items. So what tools are important to them? What clothing is important to them? What shelter is important to them? What are their wants and needs? What items are absolutely needed in their society? What are considered more like wants? All of these, their beliefs and their material possessions come together, and based on all of this, we can say, hey, this is what this culture is really all about. This is what's important to them. This is what's not important to them. And then we use that information to compare and contrast them with other cultures in other places as well. All right? What's the major difference between possibilism and environmental determinism, and which is considered more acceptable today? Okay, so environmental determinism is simple. It says the environment solely determines how your culture develops. That every culture in the world is based on the environment in which they live. So this was an idea that was really popular throughout most of geography up until about the 1900s. This was common. It led to a lot of racism and stereotypes. For instance, there were stereotypes by many geographers that said, oh, people that live in warm climates, like lower latitudes, like near the equator, they don't have as much, technology as people that live in Europe and other places. And geographers speculated who believed in environmental determinism, hey, maybe the reason is because it's so hot in the tropics and things like that. People that live there are lazy and they don't want to work as hard. And so what those geographers are doing is saying the environment explains the reason why the culture is the way that it is, and only the environment does. All right? It also talked about how, like, people living in Europe, in the middle latitudes, where it was cooler, temperate, were more productive, and they came up with more, I guess you could say, inventions and innovations because of the harsher environment they lived in than people in warmer climates near the equator. Obviously, we know that a culture today is way more than just the environment in which they live, right? Obviously, the environment isn't solely what determines who we are as people that live in Anaheim. It's a factor, but it's not the factor. So possibilism is a challenge to environmental determinism. It's a new theory. It's the most popular theory that's out there today. Environmental determinism isn't really around much anymore. Only a few people accept it. Most people have embraced possibilism instead. Possibilism says, hey, culture is a effect. The culture of a place is determined by a number of different possibilities. One is the environment, but things like, religion, alrighty, and things like language, and things like, relationships with nearby cultures all influence a culture just as much as the environment does. So possibilism is, hey, a bunch of possibilities influence the development of a culture, as opposed to environmental determinism, which was only the environment determines how a culture develops. Possibilism, basically, greatest argument is that people adapt and change their environments all the time. And if environmental determinism was true, then we'd all be victims of our environment. So, for instance, polders are a great example of in the Netherlands, where they've taken ocean and they've basically filled it with land so that they have more farmland and places to build houses on. That would be a good example of possibilism, because those people are adapting or modifying their environments in order to gain an advantage over it, which is something that an environmental determinist would never have believed could take place. Another good example is, for instance, when we drain swamps. That's a good example of possibilism. We're draining swamps so that we have more dry land to prevent maybe malaria or mosquitoes, to prevent flooding maybe in some areas. All of these are things that humans do to modify or change their environment, and it kind of demonstrates that we are not slaves to our environment, that we can adapt, we can adapt, we can change it, and we can make it work for our own purposes as well. What is cultural landscape? How's it related to cultural ecology? Okay, cultural landscape is how do the people of a culture modify their environment. If you're flying over the United States on a plane and you look down, you're going to see a bunch of different types of farms. You're going to see a bunch of ways that people arrange their homes and their communities. Each of those people has their own, each of those communities has their own cultural landscape. They've modified, they've changed, they've adapted to the landscape, to the environment in their own unique ways. And so some geographers actually study the cultural landscape of places, and they ask themselves, hey, what have these folks done to really kind of affect the environment in which they live? Have they built dams? Have they built farmland? Have they developed irrigation? All of these are ways people manipulate or modify their environment, and when they change it, that creates a landscape for that particular culture in the area that might be different or unique from those around them. How's it related to cultural ecology? Cultural ecology is really the study of this. It's the study of how people interact with their local environment and how that local environment helps to shape that culture at the same time. So the focus of cultural ecology is studying cultural landscapes and the impact of the landscape on the people and the impact of the people on the landscape itself. What is globalization, and which three places are the centers of it? Well, globalization is the spread of global ideas. Now, normally, global ideas are spread by the people or the places that have the greatest amount of wealth, power, and technology. They tend to spread ideas that the rest of the world embraces. The rest of the world tends to follow. So globalization is much more prevalent now than it has been in the past, just because, again, of space-time compression, and ideas in many developed areas have a tendency to spread and become adopted in other places much more quickly than they would have before. What three places are considered to be the centers of global diffusion? Well, the United States is one of those three centers. Europe is another center, and Japan is another center. Why? These are the areas that have most of the world's corporations headquartered. They have most of the information and news corporations located or headquartered in those places. And so they tend to spread information around the rest of the world, and what people wear in those countries, or the news that's being reported, or the music that's being listened to in those countries is oftentimes what's broadcast to the rest of the world as well. More and more and more, we are becoming a globalized world where we're way more connected than ever before. It's largely because of the efforts of those three places that spread these ideas to the rest of the world. So the United States, Europe, and Japan. What specific organizations are associated with spreading globalized ideas? Corporations. Corporations like McDonald's and Starbucks. They want to open in all of the countries of the world, and they want their symbols, for instance, and their products to be easily recognized. So they oftentimes spread advertisements. Advertising that often is centered on storylines or themes coming from the United States or Europe. And it causes folks in a lot of other countries around the world to, one, want to buy these products that are associated with wealth, power, and privilege. But at the same time, it oftentimes leads to these places kind of copycatting the United States and Europe and Japan in some ways. And so oftentimes folk traditions or folk customs might disappear because people are instead embracing these global concepts instead. Next question, what's the difference between renewable and non-renewable resources? Very simple. Non-renewable resources, there's a finite amount, there's a set amount, and it takes a long time to replenish them, or maybe it's impossible to replenish them, and so when we run out, we have no more to replace them. These are things like gasoline and oil, natural gas, oil, even wood, right? Because there's only limited supplies of forests out there as well. Renewable energies are energies that are, I don't want to say limitless, but they're energies that tend to renew or replenish before we can use them. So they kind of regenerate. And so we're almost able to use them on a limitless basis. Solar power is probably the most famous example of renewable energy. Wind power is another great example as well. A lot of green technologies, go green, are considered to be renewable. A lot of our old things like coal and natural gas and oil, all of these are there's limited amounts, there's limited quantities, and we're using them at a rate that's faster than we can replenish them. What's a network and what's an example of one? I talked about this in class today. It's in your need to know final notes. A network is when places and people are linked together in a system that connects them through transportation, like roads and highways, through communication, like communication lines, like the internet. It can be connections through business, where businesses do a lot of business with one another between places. And what forms is basically these huge connections that we can actually chart. Hey, how much money is flowing between, for instance, New York and Los Angeles and all the cities in between? Well, we can develop a money network that shows where all of the money starts and where it ends up when it leaves New York City. We can start a freeway network and look at all the freeways of the United States, look to see which ones are busiest, which places have the greatest connection, which would mean the greatest amount of people moving to and from them together. So, for instance, are Chicago and Miami more of a network, or is Chicago and Los Angeles more of a network? Well, by looking at maybe freeway maps or highway maps, by looking at business flows, by looking at flow line maps that show the movement maybe of information or of technology or of money, we can identify where networks exist. A good example of a network is an airport. If you look at an airport, oftentimes there's going to be some sort of map there that's going to show you all the locations that they fly to. And so the airport almost looks like the hub, like the center of a wheel. And then all these lines extend outward from it, almost like spokes on a bicycle going in all these different directions. What that's showing you is that airport's network. That's all the places that place connects to that you can fly to from that particular airport. All right, folks, I'm going to sign off there. If you have any questions for me tonight, I hope you won't hesitate to answer. This is Mr. M, and I hope everybody studies hard tonight. Have a wonderful night.